Hi, everybody. The focus of today's video is going to be on zero-inflated negative binomial regression. Um, First, let's talk about what zero-inflated negative binomial regression is. So, negative binomial regression is in there, so it does focus on models that are count data, just like we talked about for the last video. The difference really is where there's an inflation in excess of zeros in the data. The While there's multiple count models, when you have an excess of zeros, it's a matter of how do you deal with it. Does the count model that you're running, does it appropriately handle the excess of zeros that you might have? So what makes zero-inflated a negative binomial regression distinct, and the same applies for zero-inflated uh, uh, Poisson regression also. Um, but we're doing a negative binomial, zero-inflated negative binomial, because the same assumption still holds of that the variance is greater than the mean. So all of that still hold. It is a negative binomial regression, so you need to understand that. Just a matter of whether or not there's an inflation of zeros or not. So zero-inflated negative binomial regression assumes that the zeros come from two different processes. It's always better by example. So if you're looking at the number of times, a common example, if you're looking at the absences that students have from school, if you're thinking, for grade school kids, the number of times they were absent from school. Some kids have been absent 0 times, so have not been absent any times because they weren't sick. There wasn't no emergency, so they weren't absent from school. They were feeling well. Everything was fine. It wasn't an emergency, so they weren't absent any times. Some students weren't absent because, maybe they had parents who want to push for perfect attendance no matter what the circumstances. If they're sick, if there's an emergency, the parents don't care. I'm not saying they don't care, but parents still want to send their kids to school regardless. So there still is zero, no matter what the circumstances are, whether or not they really were not sick or there was no emergency. There's a zero there, and if they have parents who just want to push them to go to school, no matter what the circumstances are, there's still zero there. So there's an inflation of zeros. Another example is if you look at income. Some people are unemployed, but looking for work. So you ask them, what's their income? $0 is what is the income. There's also people who are not employed in the traditional workforce, such as stay-at-home parent, um, a housewife, husband. Um, you look at students who might not be working because they're in school all of the time, so they're not looking for work. Um, so if you ask them what's their income, $0 would be it for them also, even though it's two processes to how somebody might arrive at the zero. Either they're unemployed but looking, or they're not employed in the traditional workforce, but they're not looking for formal work. Zeros is in both of those processes. If you're looking at the number of times somebody was rearrested, if they committed an offense, how many times were they rearrested? If there's nothing in the data that accounts for whether or not they were released and on the street to be able to commit offenses, then that zero can come from either they had the ability to actually um, be rearrested and they weren't, or it can be that they were locked up, so they did not have the ability to actually reoffend. So 0 times would be for both of those responses, but it's just a matter of what the source of that zero was. So those latter categories are called certain zeros. So it's certain that the person is a zero. It's certain that the person is zero because for the number of time they are absent from school because their parents going to send them to school regardless of the circumstance. It's a certain zero with income for people who are not employed in the traditional workforce because they're not looking for work. It's a certain zero that the number of rearrests is zero for people who were not released because they didn't have that ability. So you got certain zeros in there, meaning there's no way for that person to get anything other than a zero. So for zero-inflated a negative binomial regression, it takes a step further and allow you to distinguish between the type of zero that's there, um, which isn't incorporated in the regular uh, negative binomial regression. As a side note, though, even if you don't have many zeros in your data, even if you can arrive at the zero at different processes, um, zero-inflated negative binomial regressions, you don't have to run it. So now I'll give y'all a way to figure out which type of negative binomial regression that you should actually run. So that being said, let's actually run some of these. So now, hopefully, you have an understanding of at least what zero-inflated negative binomial regression is. So first, we're going to use the data that we used last week, the Jordan data. So again, remember that this will be saved as something different um, on your laptop or whatever you're using. Because this again, I used this from a prior class in a prior semester. So we're going to use that data. So we want to take a look at what the distribution looked like. This is just a histogram of the data. So we're looking at the outcome, the number of rearrests. I'm kind of going through this quickly because this is in the other video that we talked about. And again, focusing on those who were released, who were on the street greater than, who were on the street for more than 0 days, so at least 1 day. Now, again, even though for this data we're using, we're looking at only those who were released, which technically means the zero-inflated negative binomial regression shouldn't be used because only one source is zeros here, meaning they actually did not re-offend. I'm just doing this to illustrate how you run it, what the data looks like, how you interpret the things, how you interpret the data, and those sorts of things. So, and I want to draw comparisons to the negative binomial regression that we did last week. So, if you look at the histogram, you'll see a significant number of zeros here, a large number of zeros here. So, this actually there's really a lot. A lot of people were rearrested 0 times. Assuming that this release equals 1 wasn't there, just follow me on this one. There would be no way of knowing whether or not the person was rearrested 0 times because they actually didn't reoffend, or they actually weren't on the street to be able to reoffend. So zero-inflated negative binomial regression will help you figure out what the source of the zeros are. So, and again, just to straight to point, let's do the one of the negative binomial regressions that we did last week. So I'm not going to focus too much on this because this is in the other video, but a negative binomial regression, looking at the number of rearrests as your outcome. The predictors in the model are age, gender, conviction, and with using that subset of if they were released and risk time is greater than zero. And here's the model. So again, I'm not going to go over that too much because it's in the prior video. One of the things that I did not show you is that you can actually store the results from this model, so you don't always have to type it over and put the syntax back in. So if you want to store the estimates from this model, the syntax is estimates store, and then you can call the model whatever you want. I just called it model one. So estimates store. So you're storing the estimates from the last model that you ran, and you can call it whatever you want. You can call it dog. It don't matter what you call it. You can call it cat. You can call it I don't know. Call it whatever. So I'm calling it model one. So now those estimates are stored. And if you actually see it over here, it actually appears right here. So estimate model one. So it actually stores it for you. Okay. So same thing we did last week. The only thing different that we stored the model. So now let's talk about how you do a zero-inflated negative binomial. So the command change is not NB for negative binomial regression, is ZINB for zero-inflated negative binomial regression. All of this syntax stays the same. But then we have this extra part here, inflate. Like, what is inflate? So this is what a zero-inflated negative binomial regression does. It does two models. The first model that it does, the first thing that it does, it provides a logit model. It provides a logit model predicting being in a certain zero category. So again, if you remember from the example, we talking about, well, in income, we're looking at income and you're saying, is somebody unemployed and they're looking for work versus somebody who's not employed in a traditional workforce, so they're not looking for work. That latter group is a certain zero group. Certain zero group. So a zero-inflated negative binomial binomial regression, what it does, it predicts the membership in that certain zero group. So for that example, like, okay, what factors predict whether or not somebody is in the zero group, meaning they're not looking for work? It distinguishes between the zeros. So for this example, because we're looking at the number of rearrests, again, put into the side for a minute that we're only looking at those who were released. If that part wasn't there, there would be no way of knowing whether or not somebody was rearrested because they didn't commit any offenses and they were able to, or because they weren't released and on the street and had the opportunity to actually be rearrested. So that latter group is a certain zero group. So the logit model of a zero-inflated negative binomial regression is predicting the membership in that certain zero group of rearrests. So it's just distinguishing between the zeros. You're either in the category where you were able to commit offenses and you didn't, or you were certain zero of not engaging in offenses. So it's two categories. So a logit model is what it's running. That's what the inflate part is right here. So what comes after the inflate, you put the predictors in here for the logit model. So again, it's running two models. Is running the model of whether or not you're in a certain zero group that comes after the inflate. You can use the same predictors as a negative binomial regression model, which is over here, or if there are different predictors, because sometimes, be like, okay, what can influence whether or not people, whether or not if you're looking at the number of, if you're looking at the income of somebody, like, okay, what factors can predict whether or not somebody is not employed because they're not looking for work versus whether or not people are actually unemployed and looking for work. So it allows you to distinguish between those categories. So the first model that it runs is the Loja model to predict the membership in the certain zero category. And the second part of the model is a negative binomial regression, where it's looking at the count model of those who are in the not certain zero category. I hope that makes sense. Let me try it again. Okay? Okay. So the Loja part of the model predicts the membership in a certain zero category. That's the Loja model of it. The negative binomial regression model, then it looks at it's a regular negative binomial regression. Regular negative binomial regression, just like we did before. However, is running the count model of those who are not in a certain zero category, meaning it's taking out those who are certain zeros, leaving them out of the model and looking at the real zeros, because there is a count, looking at the real zeros and anybody who's above, who's one or above. So I hope that makes sense. So zero-inflated negative binomial regression, outcome, predictors. Again, looking at our little subgroup here. And then for the binomial, the Loja part of the model, I'm just including age and gender in the model. Okay? Okay. So before we talk about what this model is, we're going to store the estimates here, and I'm going to call it, I'm calling it model 2. So before you talk about how you interpret what you see here, I'm going to store these estimates and call it model 2. Then you see it appears right there. Okay, so let's talk about what we see here. What we see here, you got zero-inflated negative binomial regression. You got the number of observations, but it tells you the number of non-zero observations and the number of zero observations. So you see, of the 208 that's in the sample, 84 of them are zeros. That's a pretty, that's a pretty high number. The likelihood ratio chi-square is looking at the number, is testing the null hypothesis, that and the significance is testing the null hypothesis that all the coefficients are equal to 0 in the model. Because it's significant, it's less than 0.05. That's telling you at least one of the coefficients is significantly different than 0 in the model. You see, for the inflation model, that's the Loja part of the model, whether or not, predicting the membership in a certain zero category. You see that it used the Loja model, so it's actually telling you that. So this part, the first part of the model, is your negative binomial regression part of the model. That's looking at the that's looking at the non-certain zeros. So again, just a negative binomial regression that's looking at the non-certain zeros and everybody else. So the non-certain zeros and everybody else. So the non-certain zeros and one and on. Just a regular negative binomial regression model. The interpretation is the same. For every unit increase in age, the The expected log count of rearrest decreases by 0.206. Same exact interpretation. The only difference between this and negative binomial regression is that it's taken out. It's taken out. It's distinguishing between the certain zeros and the non-certain zeros, where negative binomial regression doesn't account for that. Now, the reason why I wanted you to run the original negative binomial regression is just to compare. So if you actually look at the negative binomial regression that we ran first, the age coefficient is negative 0.327 and is significant. Here is negative 0.206, and you see that it's a little bit different. It's not significant here. Gender, 1.27, and significant. Here, 1.12, and is significant. So you see some differences between them. But again, the interpretations are the exact same way. If you look at the inflate category, what this is, what the inflate part is, what this is again, is predicting the membership in the certain zero group. So what this tells you here is that, and again, these are logistic regressions. So what this is telling you is that for every unit increase in age, even though it's not significant, for every unit increase in age, the log odds of being in a certain zero category increases by 0.70. If you want, you can convert it to odds for our ratios, and doing this on my handy calculator here, 0.702122, hitting the EX button, comes out to 2.01 or 2.02. So it comes out to 2.02. So it'll tell you for every unit increase in age, the odds of being in a certain zero group for reoffending, it increases by 102%. So you interpret it just like you do for a logistic regression. But again, you see none of these are significant, so we probably don't got good predictors here. But at least in terms of interpretation, you know what this is. The inflate is telling you the prediction, the odds or log odds of being in a certain zero category for that outcome. And we stored the estimates. So you might then want to say, one thing you can do, you can take this model, you can do the IRR, you can look at, which we talked about last week, you can look at the rates. So last week we did, it was NBREG, IRR to get the incident rate ratios. But since we're not using that command, we're using zero-inflated negative binomial regression. You can do the IRRs for that to get the rates. And here they are. As you can see, they give you the rates for the negative binomial part of it. But for the odds, they don't. So you can calculate that if you want to convert the log odds to the odds, like I just did with my calculator. So again, I'm not going to go over the interpretation of IRRs because that's on the last video. So I really don't want to waste y'all time and hear me just discuss that again. But the interpretation of the count model is the exact same as negative binomial regression, because it is a negative binomial regression. The only difference is that a zero-inflated negative binomial regression, it counts for a certain zero and a not certain zero. Like, how do you look at the zero? Is it part of the count model or isn't it? That's the only difference between it. I hope that makes sense. So sometimes you got to ask yourself, okay, is a zero-inflated negative binomial regression the best model to run, or can a negative binomial regression, which one is a zero-inflated negative binomial regression, or a regular negative binomial regression? Which one is the best one to model this data with? Well, there are tests that you can run. So if you do the command that has, is estimates stats. So estimate stats model 1, because that's what we called our first model, the negative binomial regression, and model 2, which is zero-inflated negative binomial regression. If you look at those two models, we're comparing them with one another. So estimates, stats, and then whatever you called your two models, put those in here. And I always pronounce it wrong. It's AIC and BIC, but it takes information criterion and the Bayesian information criterion. These are really tests of model fit. So what this tells you is, based on the first model, lower limit is what the LL stands for, but the null model, meaning nothing in the model, the model, meaning what all the predictors that you put in there, and it's giving you the AIC and BIC. The AIC is the Akake's information criterion, and the BIC is the Bayesian information criterion. So the lower the value, the better the model fit. Now the AIC and BIC tells you similar things. So many times they will agree with one another. The formulas and everything are different, so you'll see a slight difference here. A25 if it's the AIC, A41 is the BIC. There's still a measure of model fit. So model 1, the AIC is A25, the BIC is A41. And that's our negative binomial regression. For model 2, the AIC is A27, the BIC is A54. Lower values mean better model fit. So as you see, according to the AIC and BIC, these values are lower. The values are lower than model 2. So the AIC for model 1 is lower than it is for model 2. The BIC for model 1 is lower than it is for model 2. So what this is telling you is that the first model fits the data better, which means for this data, we don't need a zero-inflated negative binomial regression. The regular negative binomial regression fit the data better. So we don't need a zero-inflated model. So you wouldn't run a zero-inflated model. You will run both. You can see which one fit the data better, and then you can run the AIC and BIC and see that the values are lower for model 1, which tells you that model 1 is an actual better fit. So you wouldn't do a zero-inflated negative binomial regression here. And by the way, just to play around a bit, if you wanted to bring the data back and actually see what the data was, if you wanted to pull up model 1 again, you can just click on model 1 here. And there's model 1. If you want to bring up model 2, Just click on model 2. You see what the syntax is, which is estimates replay model 1, estimates replay model 2. You see that stuff is there. So that's how you do zero-inflated negative binomial regression. You could do the same thing, but have the, I ran it also when it comes to having exposure predictors, have been there. If you look at if you look at a negative binomial regression, using the same thing, but you put the exposure predictor, the exposure of risk time in there. Again, we did this last week. So you're going to store this as model 3. Again, I'm not going to go over too deep because we actually did this last week. But now we're going to do a zero-inflated negative binomial regression again. Again, the things that we put in the model with this: age, gender, convicted, with exposure of risk time. Same thing here: gender, age, gender, conviction, exposure is risk time. But again, because it's zero-inflated, you got to put what the larger part of the model is going to be here. So I included gender and conviction. Again, like, okay, what can predict whether or not somebody's in a certain zero category? So I did age, gender, and conviction, which are the same ones that I use here. And then if you look at the age of the negative binomial regression, the regular negative binomial regression, you see it's negative 0.317. Here's negative 0.203. Male 1.34 and significant. Here 1.18 and significant. You'll see the Loja model to predict a certain certain zeros. We're going to store these estimates as model 4. Oh, my bad. Estimate store model 4. Backwards. Oops. So I'm going to store those. If you want to do the incident rate ratios, ZINB, IRR, the incident rate ratios, interpretations are the exact same. But now, if you want to do the AIC and BIC to see which model handles, which model is a better fit for the data, the negative binomial regression or the zero-inflated negative binomial regression, do estimates, stats, model 3, model 4, because those are the second models that we ran that had the exposure variable in there. And as you can see, based on the AIC and BIC, they're lower. They're not going to always be consistent like this, but so we're looking out pretty well here. The AIC for model 3 is lower than the AIC for model 4, and the BIC for model 3 is lower than the BIC for model 4. So that's telling you that model 3 is a better fit for the data. So the negative binomial regression is enough to handle the model. You don't need to do the zero-inflated model with this. So this is back when I was telling you towards the beginning of the video, even if you have excess of zeros in the data, you don't always have to do a zero-inflated negative binomial regression. But if there's a different structure to the zeros, different process and how you get to the zeros, you might want to consider doing a zero-inflated negative binomial regression and then seeing whether or not, by doing the AIC and BIC, which model can handle the data the best. So I hope this video helped. I'll post an assignment on it, and I'll put up another video shortly when it comes to hurdle models. So have a good night or day, depending on when you look at this.